Hello students, today we are doing actually few questions from projectiles. Actually projectile questions you should be we all should be really good with linear motion equations, and we need to have the ability to apply vectors properly. Velocity is a vector. So if you're familiar with these two types of questions, then the projectile question is very easy. Other than that, actually in the paper actually we have seen they mix this question with linear momentum. So at a certain point of the journey, so the question will ask you that a certain object will get blasted in the middle or somewhere, and then the projections or the range will change, and where will it land, how long it would take, things like that. That kind of a question might be there. So you should not get confused by these questions. So that means you should try the questions, yes, that we need to apply conservation of momentum as well, right? You should be familiar with those questions as well. In the playlist actually, when I'm searching through, actually I saw I've given you one question there. So this question, I'm walking you through a few questions today in projectiles. So one of the questions is from linear momentum as well. So try that question. For sure you will learn something new. So let's go through with the questions now. Right students, let's start with this question. An object is projected theta angle to the horizontal from point A aiming at point B. So this is point B and this is point A, right, which is 400 meters away. Just that's given. The object blasts into two fragments x and y of the mass ratio 3:1 on its way. X and Y strikes the ground simultaneously after flying on the same vertical plane. X strikes the ground 300 meters away from A. So let's say here it's the middle, it's 300 meters, that means 100 meters away from this point. Alright, land over here, X and Y, right? And Y strikes the ground at D distance from A, from this point. So that's basically, that is what they're asking from us. Okay, T is equal to, right, let's try the question now. So as I mentioned you earlier, we need to, this question actually combines with the linear momentum, conservation of linear momentum here as well. So let's start with the initial data they have given. Now it's 400 meters away, right? So let's write the equation here now. So horizontal velocity is v cos theta, that we all know. So I write the equation v cos theta, the total time equals 400 meter. I hope you all know what I applied here is h equals ut plus half at square, right? Then after the motion, after the blast here that happens over here, actually in the question they are not telling what is the point where the blast takes place. Anyway, so I'm going to assume it's on the top position. So at this height, actually in the question they should give it like that. So let's make that assumption. Otherwise it's really difficult to do the question. Anyway, right. Then this is the mass ratio. So what I'm going to do is I'm going to apply the linear momentum here. I'm going to take the mass of x as 3m and y as m. So the total mass will be 4m, right? So let's apply conservation of momentum here then. 4m v cos theta, that must be equal to 3m v1, let's say the velocity after collision, that's v1 and v2, 3m v1 and v2, we have the second equation. Of course mass cancel off, so we are getting v cos theta equals 3v1 plus v2 as second equation, right? Now there's another data they are telling us, 300 meters away, right here, this point. That means from the middle point it's 100 meters away. So we can apply again v1, that's the velocity of x, horizontal velocity of x, that into, actually that now here what we can observe is that the total time if the total time is t, halfway it's t by 2, the other way it's t by 2. Whatever the horizontal motion it is, the vertical motion is same, so we can take it as same time to the other half as well. So it's v1 into t by 2. That must be equal to 100. Let's simplify it a bit. v1t equals 200, and we have the third equation. So we have 3 equations. I hope from these 3 equations we can get to the answer. Right. Let's move into. Right. Let's do the simplification now. Right. So 200 equals v1t, our third equation, and of course we can connect the first equation, that is v cos theta, actually here, into t, that is equal to 400. So I can divide these two, so I'm getting 1 over 2 equals v1 over v cos theta. I can conclude v cos theta equals 2v1. Yes, so here this one now I can replace here in the second equation. So let's try that. Then 4mv cos theta, instead of v cos theta I can write down, yes, v 2v1 equals 3v1 plus v2. So I'm getting 8, m is not there, 8v1 equals 3v1 plus v2. So 5v1 equals v2. That's another equation. From this we can write the last equation. What's the last equation? The distance traveled by the v2, or the part y. Right. Right now the distance traveled by the part y. So part y, the velocity is v2, the total time is t by 2, that should be equal to d. So let's write the same equation for v1. Here for v1 it is 200 equals v1 into t. So what we have to do is we can divide these two equations. Actually we can write down v2 from v1, vice versa, right? So v2, of course, it's 5v1, that into t2 equals d. So let's divide these two equations now. Right. Then I'm getting tt cancel off, 1 over 2 goes off, so 2 over 5 equals 200 over d. So 2 cancel off 100, and then d equals 500. Right. That's not the answer yet. So they're asking d distance from A. So we have found here now that x, or the y will travel 500 meters from this point. So it has already traveled 200 meters to the middle. So the total value 200 plus 500, that will be 700 meters. Yes, bit of a challenging question, I know, but you have to practice these type of questions. Even simultaneous equations, that ability also, that is really valuable here. You have to have that skill as well. So I hope you students, you understood something from this question. Maybe there are plenty of other methods that you can easily solve these questions. If you have any suggestions, yes, you can comment down, no problem with that. So we all can learn something new. There might be an easy way for doing this question as well. So any suggestions? Yes, sure, any suggestions welcome. Right, I hope you learned something from this. Try lots of questions. You will be good to go with the exam. Right, students, this question, actually it is not a projectile question, but you need the projectile knowledge to get the answer. So let's try this question now. An object projected 200 meters per second, velocity at 60 to the horizontal, blast into 3 fragments here of similar masses at the highest point of its path. After the blast, one fragment moves vertically upwards, right? So one goes up and 100 meters per second, right? 100 meters per second. Velocity and another at the same speed vertically downwards, right? 100 meters per second again downwards, right? And the speed of the third fragment is. So basically I hope you understand we need to apply the conservation of momentum, linear momentum, m1 v1 equals m2 v2. One thing you should clearly know that we cannot apply conservation of linear momentum in projectile motion because it's under gravity. So there's an external unbalanced force, right? So here we can apply this law only at the highest point because it is actually we are considering only the horizontal direction. So horizontal direction or the horizontal velocity won't change, so horizontal momentum will not change as well. So we can apply only up to this point, only at this point, right? So initial velocity, let's assume, so v cos theta, let's see, velocity is 200 meters per second, then horizontal velocity will be 200 cos 60, 200 cos 60, right? Cos 60, right? Cos 60 is half, so it's 100 meters per second. That's the velocity when it is blasted. So let's assume that mass, initial mass is 3m because it's 3 fragments of similar mass. So total mass is 3m, 3m into 100, that's the initial momentum in this direction. So then what actually happens is one m goes up and the other goes down. That means initially there was no, yes, at this point actually, at the highest point velocity, vertical velocity is 0. So we can assume, so we can come to the conclusion that there's no linear momentum, vertical linear momentum. So vertical linear momentum at the beginning is 0 and at the end it's 0 as well. So upwards and downwards cancel off, so no vertical momentum. So the third particle will not have any vertical motion, right? So then 3m, so the final one is, final remaining mass is m into v1 horizontal direction. So we can conclude it's 300 meters per second. The question is easy, not that hard, but you need to have the knowledge in projectile motion questions, right? So this is the answer, the third answer. It's an easy question, but what I'm suggesting you students is you have to go through projectile motion questions because this question can go up to even any other even in momentum questions as well. So we are basically getting actually 2-3 questions, more than 10 to 12 questions in MCQ paper. It's always better to be practiced with these type of questions because it will improve your analytical skill for sure. Even it will be really helpful when you are doing other questions as well.